So today we'll discuss refraction through a prism, the derivation part. We will take your NCERT book. Mute yourself. Okay, listen. Refraction of a light through a prism. So last class we discussed what is angle of incident, angle of deviation, and angle of emergence, angle of the prism. Now I will take on A, P, O, Q. Okay, this one. A to P, again O, Q. One second. A, P, O, Q. So this is quadrilateral APOQ. Now A plus O, it is equal to 180 degree. A plus O. A and in this angle, A angle, O angle. A plus O, it is equal to 180 degree. Okay, next. Next triangle OPQ. Next triangle OPQ. OPQ. So OPQ means see it is also equal to 180 degree, but we should take two angles R1, R2, and 0 O also. 60 degree, 60 degree, 60 degree. In triangle it is 60, 60, 60. Now angle R1, R2, O. Equation number 2. Two steps completed. Third one. Triangle DPQ. 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 For in this triangle, the delta angle of deviation. Now, in this delta it is delta equal to I minus R1 angle of incident minus R1 for this one. I minus R1 This is angle of incidence. In this angle R1, I minus R1 plus E minus R2. E means angle of emergence minus refraction 2 for in this area R2. The next step, I minus R1 plus E minus R2 it is minus R1 minus R2 it is so that R1 plus R2 overall minus outside. So I plus E minus R1 plus R2. RD you know very well from equation number 1 and 2. A plus O it is a 180 degree. R1 plus R2 plus O it is equal to 180 degree. Okay. So delta equal to R1 plus R2 is and the value is A. Just you apply the value, then you will get delta equal to I plus E minus A. Otherwise, I plus E equal to A plus delta. Last class we discussed only the formula. Now it is a derivation format. Diagram, equation number 1, equation number 2, 3. We go for the last equation. Just take a note up to equation number 4. See here, A equal to 180 minus 4. For here also, R1 plus R2. It is equal to 180 minus 4. So what is the value of 180 minus 4? That is the A. Then the formula A equal to R1 plus R2. That's all. Incident angle plus emergent angle, the sum of incident and emergent, it is equal to the sum of angle of prism and the angle of deviation. In this statement also you should copy. Okay. So next one, variation of angle of deviation with the angle of incident. It is there in your practical syllabus also. The main concept, the angle of incidence increases, the angle of deviation also increase. 40 degree it is there, I will get around 44. Angle of incidence 40, angle of deviation 44. Next to 45 means it will definitely increase 47 or 48 or 49. Angle of incidence increases, the angle of deviation also increase. Next one, angle of minimum deviation, the definition. The particular value of angle of incidence, the angle of deviation become minimum. It is called angle of minimum deviation. One more question. Define angle of minimum deviation. The angle of incidence, the angle of deviation becomes minimum. So in this point, it is a minimum. Okay. It is called as angle of minimum deviation. So in this situation, the I value equal to E, angle of incidence and the E value, both also equal. Now R1, R2 also equal to R. Before only we discussed A formula. A means what? Angle of prism. A is the angle of the prism. Delta angle of minimum deviation R1 and R2. That is a refraction 1, refraction 2. Now both are also equal. R1 plus R2 equal to R. Then 2R. A equal to 2R. Then R equal to A by 2. This is equation number 1. Before only we verify, and the sum of angle of incidence, angle of emergence, it is equal to angle of the prism and angle of minimum deviation or angle of deviation. So I plus E, I value, E value, both also equal. Then you will get 2I equal to A plus del M. Then I equal to A plus del M by 2. Using Snell's law, the angle of sine angle of incidence divided by sine angle of refraction. I value A plus del M by 2, R value A by 2. Just apply the value. This is equation number 2, equation number 3, equation number 4. The variation of angle of deviation with angle of incidence. And a graph also. Please take a notes. Last time, exam time, I shared one PDF mark that a plan, down link it is there. All the chapter 1 to chapter number 14, all the chapter e-book it is there. Based on lesson, you can download. One second, again I will show you. Chapter number 1, 2, 3, 4, 5, 6, and 7, 8, 9. Now we are discussing 9th chapter. Just click. Okay, next topic. Refraction by a small angle to prism for a small angle of incident. New formula sin I by sin r. But sin I it is they equal to r e. So that again I am taking equation number 1. This is equation number 2. Sin I by r1, sin I that is the angle of emergence, r2, sin r2. I consider the value of I incident angle is very small. Then r1, r2, e value also it is very small. So no need to take the sign value, directly you can mention mu is equal to I divided by r1, mu equal to e divided by r2. So LHS equal means RHS also equal. Let's class multiply. Mu1, mu r1 mu r1 equal to I mu r2 equal to e. Just to add, this is equation number 1, equation number 2. I will take common out mu r1 plus r2 I plus e. So r1 plus r2 means it is a. Okay, I plus e equal to a plus delta. Mu a it is equal to I plus e. This is equation number 3. And before formula it is I plus e equal to a plus delta. Now I plus e it is equal to mu a. That is the fourth equation. Mu a equal to a plus delta also. Equation number 4. And again simplify that, you will get delta equal to a into mu minus 1. Equation number 5. So definitely in this formula relevant, one question it is a 1 more question or 2 more question or 3 more. But very important formula. Formula number 1, 2. This one considered to 1 more. Equation number 1, equation number 2, 3, 4, 5. Please take a notes. and this is e-bookmark. Okay, chapter number 9. Study material, NCERT book and solution, and assessment. Once again, I will use the voice.
Deviation of any two colors is said to be angular dispersion of the two colors. The angular dispersion of red and violet colors may be given by dispersion. The difference between the angles of deviation of any two colors is said to be angular dispersion of the two colors. The angular dispersion of red and violet colors may be given by delta V minus delta R is equal to A into mu B minus 1 minus A into mu R minus 1. By simplifying, we get delta V minus delta R is equal to A into mu V minus mu R, where delta V is the deviation angle of violet color and delta r is the deviation angle of red color.
Listen, we know that the delta equal to A into mu V minus mu. That is the range mark. V minus R means range. Delta V minus delta R, range formula. Deviation angle of violet color, deviation angle of red color. So red is the minimum deviation, violet is the maximum deviation. Okay, that is the V minus R. That is refractive index V minus refractive index R. So every color there is some different refractive index. It is the A, that is the angle of the prism.
For thin prism of refracting angle A, the deviation angle is given by delta is equal to A into mu minus 1 delta, where mu is the refractive index of the material of a particular color. From the formula, delta V minus delta R is equal to A into mu V minus mu R. Therefore, we can say that the angular dispersion depends on the angle of the prism and the refractive indices of the two colors.
It is one more question. Angle of dispersion depends on two conditions. One is angle of the prism A value. Another one, refractive index of two colors, minimum and maximum, violet and red. For in this situation, violet and red.
Dispersive power, omega. Dispersive power is defined as the ratio of angular dispersion between two colors to that of their mean deviation. The angle of prism does not affect dispersive power. Let us consider two colors, say red and violet. Then, the dispersive power of the prism, omega, is equal to the angular dispersion between violet and red colors divided by the mean deviation of violet and red colors.
Please note the formula now. Dispersion power, the ratio of angular dispersion between two colors to that their mean deviation. This is omega, not for W, omega. Okay, next step.
Therefore, omega is equal to delta V minus delta R divided by delta V plus delta R divided by 2. That is, the mean color of violet and red is yellow. Therefore, delta V plus delta R divided by 2 is equal to delta Y. Let this be equal to delta. Then, omega is equal to delta V minus delta R divided by delta, which is equal to A into mu V minus 1 minus A into mu R minus 1 divided by A into mu minus 1, which is equal to A mu V minus A mu R plus A divided by A into mu minus 1. Therefore, we get omega is equal to mu v minus mu r divided by mu minus 1, where mu v is the refractive index of violet color. Mu r is the refractive index of red color. Mu is the refractive index of yellow color.
Please note that last formula omega equal to A mu v minus mu r divided by mu minus 1. Mu v means refractive index of violet color, mu r refractive index of red color, mu refractive index of yellow color.
Hence, we can say that dispersive power of the prism depends on the refractive index of the prism, and it is independent on the angle of the prism. If we consider blue and red color, then we get omega is equal to mu b minus mu r divided by mu minus 1, where mu b is the refractive index of blue color, mu r is the refractive index of red color, and mu is the refractive index of mean color of blue and red colors. (4,861 angstroms, 5,890 angstroms, and 6,563 angstroms are the wavelengths of F, D, and C respectively. Fraunhofer lines in solar spectrum are in the region of blue, yellow, and red of the spectrum. If mu F, mu D, and mu C are the respective refractive indices of 4, F, D, and C lines, then the dispersive power is omega is equal to mu F minus mu C divided by mu D minus 1. Comparing the dispersive powers of flint glass and crown glass, we get that the dispersive power of flint glass is greater than that of the crown glass.
Okay, ma'am. Thank you.